Hi, this is Pramit Kumar Senapati from GD&T Easy Academy, and in this particular video series we'll be discussing about the datums. So what is exactly your datum? Let us unfold the secret. And many people, they wonder while applying and while decoding GD&T, and they used to get confused. What is the datum? So really, is that inside the part, or inside your inspection instrument, or maybe inside your machining device like the VMC instruments, or maybe the CNC where you machine your parts? If you look at this particular slide, you will get various different components. Like this particular machine or instrument is used for measuring the components cylindricity, and here you can have your runout, here you can get your flatness, and this is basically a VMC machine, and this also, and here you can see the machining sequence by using the tool, and these are the manufactured parts, these are also the manufactured part. So when you apply GD&T in your part, so what exactly is your datum? So many people, they get confused, the datum A, datum B, datum C, and many other datums, where that lie exactly. So is that inside this, or inside this, or where? So before unfolding the secret, let me give one small example. If you are trying to apply GD&T over this particular part, so you constrain the various degree of freedom, like the translation, 3 translations and 3 rotations. So what about those translations? Where do you fix, and how do you measure it that all assigned tolerance and dimensions are in line with your configured interference, like the rotation and your translation, those all the degree of freedom are arrested or not? So for exactly understanding this, I will be explaining you about the datums and 3-to-1 rule. How do you apply that? And after that, you will be understanding that where exactly is the datum. So for your information, just keep this thing open, and later on I will exactly show you where is the datum. And many people, they confuse in this 3 domain, maybe in the inspection instrument, maybe inside your machining interface, maybe inside your part. So where exactly is that datum? So datum again is of 3 different types. One is the datum feature, another is the datum simulator, and another is the absolute datum. So let us first understand the datum concept by understanding the 3-to-1 principle. Then I will come back again and I will show you that where exactly is the datum. So if you see the 3-to-1 datum concept, or you can see the principle, that is the key, and after understanding this I will relate it. So if you see this particular figure here, this is the part and this is the gauge quality surface, where you will be comparing these surfaces, that whether these are correct in line with your tolerance component or not. That means the datums are always with reference to the absolute or perfect datum, or you can say the gauge quality surface. There your datums are lying. That means the component is just for the reference or the datum feature. That means whatever the datum you are using, like A, B or C, are never inside the part, but those are inside the gauge reference, or you can say the inspection instrument, where you do refer those surfaces for comparing the difference or the variations, or maybe the surface quality. That may be the straightness, that may be the flatness, that may be cylindricity, that may be anything. But before going through that, let us understand the 3-to-1 principle. So if you talk about this datum reference frame, or you can say this particular area where the datums are there, the feature control frame, and this particular area is the datum reference frame, the primary datum. secondary datum and tertiary datum. This is the first datum which restricts the 3 degree of freedom, and the second datum, that is the secondary, will restrict 2 degree, and the third one, the tertiary, will restrict a single degree of freedom. Let's understand how. So when you keep this particular part over this particular surface and just imagine these two sides are not there, then this particular plate surface will restrict its translation along this vertical direction, along this direction, and also it cannot rotate around this or this plane. That means it restricts 3 degree of freedom. So this is about your datum A, and these two are still we need to apply over the part. So when you talk about the second datum or the secondary datum, then what happens is, let us introduce another gauge surface where it will come and hit there, and forget about this third wall of this gauge which you are seeing here. And what happens is, this cannot move around this direction. That means another translation is restricted, and also it cannot rotate around this G axis or whatever the vertical axis you have. Again, it restricts the 2 degree of freedom. And the final one, when you will put, it restricts this translation along this direction. So in this way, the 3 to 1 datum features are always reference with respect to gauge quality surface, that is your inspection instrument. So if you talk about this particular part, then what happens is, wherever you talk about the datum primary, that restricts. So always we keep datum A never over a thin area. So I will never suggest to place your primary datum over this thin area, because it cannot restrict all the degree of freedom perfectly. So a flat larger area where you have the protocol of this 3 principle or the first primary datum, there you have to always prefer a large area. That means if this particular part you see this thin area, there you can never have a datum A. But many people, they by mistake they consider that this thin area can be just you rotate this and keep it the vertical, and this will be your primary datum, or maybe the bottom side, or maybe this side. Never. So the larger area, that means this particular plane, will be your primary datum, and this can restrict 3 degree of freedom. Just like that here you can see in this particular example, or maybe this particular example you see where the base, this particular disk where the base is referred as the datum A. So the 3 to 1 principle is the key while understanding this. That means if you look at this, so datum never lies here, only the datum feature we referenced is always here. That means your inspection instrument, here you have your gauge quality datum or the perfect datum which you refer, and that is the key where your datum is lying. And if you see the particular calculation which will be your primary datum, if you look at this particular figure, and if you see this particular side where you have the flatness and you have the datum A, that means this big surface where you have the larger area, you have your datum A. So during the calculation or restricting the 3 degree, even you select this also 3 degree will be restricted, but you know the wobbling or the rocking motion cannot be restricted or arrested properly. So always choose your primary datum at the larger surface where you have the mathematical interface for controlling the degree of freedom to the greater extent, and you get good quality, you know, the inspection also. So in this way, if you see, look at this, the datum A is this larger one, and then you can select another one, the flat surface, as your B, and the another one is third, which is not perpendicular but at an angle. You can see the angular interface you have controlled through the datum C. So this is the datum which is theoretical, but this is the gauge quality where you are referencing your part. You can see the particular gauge where you are using this, and in this way you can really come out of your confusion and really interpret where your datum is lying. Hope this particular series will definitely help you in understanding, or you can say your confusion or wrong interpretation of datum. Thank you.